Okay, this is Diffie-Hellman key exchange. So we know what symmetric and asymmetric is. Everybody understand that? Symmetric is same key. Well, how am I going to get the key to the other guy? Well, I can use Diffie-Hellman to get the key there. Okay. So here's how it works. So Alice and Bob, those are always our people here. Alice and Bob, they share a Diffie-Hellman group, which would be GP in this example. A large prime number P and an integer G. That's what they're sharing. Okay. Alice would normally choose the G and P and shares it with Bob. Okay. So that she chooses it, shares it with Bob. Then Alice generates her own large random number integer, X, and sends the half key. Now remember, the G she already has and the P. They both have G and P. Remember that? Y'all got that? Again, this is another assignment that's very simple. G and P, they both have. So Alice generates this small x right here, does the math, and comes up with the large X. Okay? The small x is usually a very large number. Bob, again, has shared G and P with Alice. So Bob generates a large Y and does the math and comes up with the big Y. So far, so good? And that's called the half keys. All right? Then they compute the key. Okay? Because remember, Alice now has the big X, but Alice also has this and Bob has this. Okay? It's Alice and Bob. Yeah, that's how it works. Okay. So we're going to walk through this and see how it works. The key is at least as strong as the strongest half key. So if Alice picks a small, in other words, a not large X, it'll be an easier number to break. So as long as they're usually about 180-bit random number, they're good. So it says neither Alice nor Bob can completely sabotage the resulting key because they don't know all the values. Bob does not know what Alice picks for X, and Alice does not know what Bob picks for Y. So they can't screw it up. And if the half keys match, they know it worked. The half keys did not match, the entire process is screwed, so it doesn't work. So it's not like, you know, they can, it's either going to work or it's not going to work. If they match, it worked. If they didn't match, something went wrong. Okay, but there is an issue, no authentication of participants. Still, I don't know who Alice and Bob are. I mean, do they know each other? Probably not. No prevention for replay and no protection against denial of service. Now let's walk through this. Consider this Diffie-Hellman key exchange. This is exactly like your homework. With G of 3 and P of 353, where Alice and Bob pick 97 and 233. But remember, Alice and Bob would not be sharing the 97 and 233. They would not be sharing that part. They keep that to themselves. So remember, the X and the 97 is what Alice picked. See this 97 right here that Alice picked? So that 97 is that small x. And they share G and P. So 3 to the 97, mod 353 gives us 40. And this small y right here, this 233 is what Bob picked. So remember, we shared the G and the P. So 3 mod 233 mod 353 gives us 248. Now for the key, we just use the 40 and the 233, then the 248 and the 97. And the results are the same. Works every time. And that's all there is to this entire thing. It's very simple to do. Writing a program for this is super crazy easy. Okay, see how that works? Okay, here's another example with smaller numbers this time. Good. So the G and the P, the 2 and the 11 are shared. They both have 2 and 11. Alice has a 6 and Bob has an 8. So remember, the 2 and the 11 are shared. So Alice does 2 to the 6, the mod 11 gets 9. Bob does 2 to the 8, the mod 11 gets a 3. So now we know the big X and the big Y. Then we do 9 with the 8 and 3 with the 6. and we end up with the 3. And that's it. There's our key. They match. Those are considered half keys. So, I mean, the math behind this is so crazy simple. And if you can't write a program to do this, I mean, you got a problem. Okay. Now, I think on the homework, I'm requiring you to give me both half keys. But they should always match. Do you agree with that? If they don't match, guess what? Something's wrong in your work. So if you're going to do it and you get the half keys, the bottom here, that don't match, then something's wrong with your math somewhere. Redo it until they match. So if they don't match, your answer is wrong. Be okay with that? That's it. Very short one. Very short.